Hey, what's up guys? In this project, we'll show you how we built this hypnotic gear mechanism. This is called a reciprocating rack and pinion, and it's a mechanism used for converting rotary motion into linear motion. We used Adafruit's Crickit and Circuit Playground Express to drive a DC motor and change the speed of the gear. When this wheel rotates, the teeth engage the lower track and travels the length of the slot. When it reaches the end, it clears the track and catches the upper part, allowing it to run back and forth. We used Adafruit MakeCode to program a simple speed controller using the buttons on the Circuit Playground Express. With the Crickit extension, you can program motor blocks and change the motor speed using variables and the on-action code blocks. We can also play with the neopixels to light up and change brightness. We designed the mechanism in Autodesk Fusion 360. The assembly is made up of components that are parametrically driven. This CAD animation demonstrates how all the pieces fit together. The design source is free to download so you can build your own. The links are in the description. We prototyped the mechanism using chipboard. Chipboard is a material that's easy to work with and can be cut using a laser cutter or a vinyl cutter. With a vinyl cutter, we were able to make very precise gears and tracks. This helped us prototype larger parts and iterate more quickly. The wheel is secured to a hub and spindle with a machine screw. The two parts are keyed and press fit together. The drive hub assembly travels the length of the slot. It's also made from two separate pieces. The center of the spindle features a threaded insert that was heat pressed with the tip of a soldering iron. This is a great technique for making perfect screw threads in 3D printed parts. Two machine screws secure the spindle to the drive hub together with these hex nuts. The shaft of the motor is press fitted into the center of the hole. Here's the drive hub in motion connected to the DC motor. The motor housing is secured with two long screws and hex nuts. A third screw is threaded through the tab, making it really tight and secure. The drive hub assembly is press fitted into the shaft of the motor. It needs to have a tight tolerance in order to stay secured. The wheels key onto the tip of the spindle and it's able to turn the gears in the DC motor. When it's secured, you get very little wobble and a nice and steady rotation. The eyes can pop in and out of the sockets without having to use glue, which I think is a nice feature. The track assembly is made up of 3 plates that are held together with screws. They're secured with hex nuts on the back. These screws are quite long and fasten through all 3 plates. The feet stands feature 2 mounting tabs that clip onto the plates. With the screws removed, you can see how the plates are stacked together. The track fits over the base plate and the motor track goes behind. The Crickit is secured to our 3D printed mount with machine screws, and we put this together in a previous project. The wires from the motor are secured to the screw block terminals on the motor section of the Crickit board. You can use jumper cable extensions to extend the motor wiring. This way you can easily connect the wires from the motor. This AA battery pack is secured to the bottom of the mount with more machine screws. The DC barrel connector plugs directly into the jack on the Adafruit Crickit. A full step-by-step tutorial for this project can be found on the Adafruit Learning System. Thanks so much for watching and be sure to subscribe for more 3D printed projects from Adafruit.